spanner. This is 8 inches long spanner, almost 17 to 18 number. Material steady. Sorry, simulation is steady. Is steady. Now steady. Of course, steady. Apply plus material. We choose material 1020. That is the over specific or over spanner material. Mashing is necessary because mashing distribute into a tiny pieces, so the system can calculate the stresses and the many more calculation. It's necessary for the calculation for the system. If you do not done it, the system cannot simulate and show the result. Fixed geometry, sorry, this is the fixed geometry. When we apply the force, normally the nut is lock the spanner from this face and this face. So we fix the geometry. The spanner cannot move from here, the two faces. Okay, we done it. And we have done all. Yeah, force. We didn't apply the force right now. Actually, we cannot apply the force because force is a linear direction, and we don't use spanner in a linear direction. We move it, we rotate it. So we need to apply a torque. The torque where we apply, this is the face of the apply the torque, and direction we have to select from here. Yeah, this is the direction. Actually, look, that is the direction. If you see, that is the direction of a force, of a torque. Okay, it's all done. Run steady. We got the result. Now we see this is the pressure point of our spanner, and this is the most uh, affected points of our spanner. You can see we can use as a spanner animation also. Newton meter. Okay, we got all of this. Steady animation is too fast. Stop it and frame it up. 50 frame and speed is slow. That is the speed, the frame per second, and that is the frame which is applied. Play. Now it's calculating, creating frame. You can see it's created, it's done. Now we see the result. You can see when the force is rising. That is the most, what can we say, the most not a danger, but it's it's facing a lot of tension and compression. Usually we see this, the tension and compression on the every bench and everything. We can also talk about it. Actually the force is applied from the clockwise, so this side is from the compression and this side is from the tension. The force is here we call compression, that is called the force is applied on the left side is called the tension, because it's pull on it push. It's all done. We can analyze another way also. We cut it, we don't need, so open it and isolate it. That is the another point of view. We can, that is the force which is facing. If we increase the force now, that is the area which is most facing the stresses. That is the most what we can say, can be break from here over the spanner. That is it. You can see. Now you can animate again and see what happened. Now you can see the spanner building a force. Stop. Let's see how the force is distributed when you apply it. Let's see. This part is still neutral. This part is still neutral. Center part are still neutral until the force is about I don't know what is something blue area. Yeah, but it's almost a 1.5 or something. Okay, let's see. You see. Let's see another point of view also. Dimension. You see the dimension. That is the dimension view. The red spot is the dimension 4.46 10 to the power minus 3 mm. The displacement value is this. The maximum value is this. 4.486 multiplied by 10 to the power minus 3 mm. It's a tiny displacement, but it is. We can also animate it. See the animation. Strain is a very complicated value, which is very useful for design and analyze the things, material, plastic, and many more things. Because the strain is a value which is made fatigue value. Is deformation, permanent deformation is called the strain. Or material can be the permanent deformed, so its shape is not particular to face the force which we applied. That is the value. That is the high value area of a strain. That is the high value area of a strain. Usually see that there is a strain where the stress and strain are both are same places usually, but sometimes the geometry is basically the geometry is select the value of a strain or place of the strain. Normally we see this the geometry of the strain is same as a stress and strain the same plot. You see another thing that you notice that the center value is also a neutral until now. Center value, as we talked about earlier about the strain is same like that. Center value is neutral, and this is the compression and this is the tension, but strain value is built here and here. Okay, we got it. And another study when we apply the force spanner in the lever way, that is the other interesting study you should know about it. If we apply the force on a spanner like a lever, so what happened with our spanner? Let's see. Study, we have done the study. Material, we select the material again, 1020, okay, apply, and fixed no, first mesh, okay, we have talked about the mesh before, why we do mesh, and material fixed geometry. Now that is the different point. Now this is the fixed geometry right now. Use a spanner in a different direction. What happened? Let's see. That is the fixed geometry right now, and the force is applied from here. From here. If you use a spanner like a lever, so we have to apply the force from here. Now run study. We have done. Let's see. This is the stress value again. This is the stress value. This is the stress value. But see this, there is a tiny stress value more than this. Actually, this geometry of a spanner make it not useful because this value is high. The stress value is very. Another feature, the center value is still Newton. The edges of it, look, the geometry make it more breaking point 1 and 2, 3 and 4. Actually, the hole that the spanner is making it, what we can say. Let's see another point of view. ISO. Let's we can increase the value. Now we get the value of a point of the stress. If we apply the force from the side of the spanner, that is not the right way to use the spanner, but we usually use it. This is the spanner. This is the point. This is the point. Or this is the point. Displacement also, we study about the displacement. This displacement. You see displacement. You see the displacement another point of view, and it's interesting. We see the stress value start from the here. This is the main stress value here. Now we see the displacement also start from the here. Let's see. Displacement. Let's go down, 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 down. Let's see. See, this value is still constant. Let's see. Displacement starts from here, almost here, because the geometry, that is the point where displacement occurs. That is the point. The strain, also show the strain. We see this, where is the strain, there is the stress. See, we got it. We know that. We can visualize that. The study is hopeful for you. If it is hopeful for you, please like the video and subscribe it, because we work on the different kind of things for fun, for knowledge, and we want to share you about the knowledge. Thank you for watching, and